Alright, hello everybody. Welcome to the introduction to the King of Fighters 11 and the NeoGeo Battle Coliseum data miners. So I'm just going to be introducing what both tools do and a general idea of how to use them. So we're gonna begin. Okay, so the general thing is that both tools work the same. Both games are based on the same engine, and what I explained for King of Fighters 11 will work for the NeoGeo Battle Coliseum tool too. So a first requirement is that we're going to be using the Japanese version of King of Fighters 11 and the Japanese version of NeoGeo Battle Coliseum. I believe the American versions work too, but I'm not 100% sure. If somebody could test that for me, I would greatly appreciate it. So I have a personal backup of my own copy of the game. If you're using a disc, it should be fine. We're going to be using PCSX2. This is a PS2 emulator. It's a very good emulator. Just get the latest version and that will work. Okay, so we're going to need a cheat engine. These tools work with cheat engine, so we're gonna need it. Alright, so we're gonna need to open the game. We're gonna need to have the game running, and we're gonna open cheat engine. And first, we're going to select the process. So we're gonna look up where is that guy? We're gonna look up PCSX2. There we go. And then we're going to open the dataminer.ct file. Alright. So once we open it, we'll have a small window right here. Well, it says object and there's some zeros, a line of zeros. So in order to use the data miner, we're gonna go to table, show cheat table Lua script, and then we're gonna press execute script. We're gonna close this, and then we're gonna press the start diagnostics button. There we go. Alright, so now after we've done all that, we're gonna get a new window called hitbox viewer right here, and we're gonna have a list of objects. So we're gonna go ahead and select player 1. This list of objects is all the players in the game. So for example, player 1 to 3 is the first team. So if I tag out, you can see that player 1 is no longer displaying any collision information. So we switch to player 2, which is Kensu, and now we can analyze whatever is going on with Kensu. Alright, and by the same token, if we go over to player 4, that would be Kyo. And if I tag out, player 4 is no longer active, but if we switch to player 5, which is Yori, we can see that we have selected him, and we can analyze his data too. So, I'm just gonna tag back and head back to player 1 and go back to Athena. So this tool will display the hitboxes, and as always, the blue color is the hurt box, and the red color is the attack box. Sometimes a yellow colored box may appear, and that's usually for throws. Okay, so one of the more advanced aspects of this tool that I want to introduce is that you get some more information, such as velocity, the difference between the two previous velocities, and also some acceleration and position data. Alright, so I'm going to introduce the advanced options. So first we're gonna choose standby. And then, for example, we're gonna choose log velocities. So if we choose log velocities, we're gonna get a pop-up which says Lua engine, and it's gonna list a small list over there. and I'm going to recommend to choose to disable show on print, because otherwise if this list keeps on getting populated, it's going to be hard to go back to the data miner and to stop the process. So we can select many different things from here. For example, we can log the animation numbers, which is the numbers used by the memory in order to describe each animation. We can also log the velocities from X and Y, so these can be analyzed later. We can log position changes, that is just plain the difference between one position and the other every frame. And finally, we have what I call the caddy machine mode, which produces this kind of output. So we're going to be focusing a bit on the caddy machine mode now. So one of the interesting aspects of my tool is that I programmed a way to output the collision boxes in a readable format. Well, actually a little more than just the collision boxes. I programmed a way to output the entire animations, including timings and timings, which sprites should be used, their alignment, and it is all displayed in a very user-friendly format. So we're going to be taking a look at that now. Alright, so first I would like to point everyone out to the Spriters resource. So in the Spriters resource they have a King of Fighters 11 section, and you can find sprites for every character here. And these sprites are very useful because every single sprite has the same ID tag as the game memory dictates, and this ID tag is going to be very important. So just to produce an example, I'm going to be looking at the sprite set of Athena. Okay, so here is that sprite set, and every sprite has a special number, and this number actually corresponds to what the memory uses to identify every sprite. So caddy machine will log in this output window the animations as they play out. So for example, let's try to analyze what happens with her heavy punch, right? So we activate caddy machine, and this is the stance animation. It's logging the stance animation right now. So I'm gonna press the button. There we go. We're gonna stop. So caddy machine produced some output. So I'm just gonna copy this, and I'm going to paste it in a notepad window. Alright, so I'm just gonna paste it. There we go. So caddy machine produced this output. So I'm going to try to explain it as best as I can. So this right here, it says begin action and then a number. So this is the name of the animation. Then finally we get something called CLCN2. So these are the collision boxes. So this is the collision box for this frame. So the format is you get a collision frame, and then under you get the information for the sprite. And then as you can see, there's no collision information between this sprite and this sprite, between lines 5 and 6. That means that the same collision box is used for this sprite, the sprite in line 5, and the sprite in line 6. That's how caddy machine prints the output. So if there's no collision box here, you should be using the one that was previously printed. Okay, so if we keep going, eventually we're going to see something called CLCM1, and this is an attack box. So we have one attack box in this sprite right here, and then another attack box in this sprite right here. And like before, since there is no heart box here, remember the heart box is CLCN2, you have to use the previous one. So this heart box is used for this frame and this frame. So someone that is familiar with the Mugen fighting game engine will recognize this code. So this code is actually the same format the Mugen fighting game engine uses to define animations, which is portable, easy to read, and there's tools already available for displaying this type of format. So I'm just going to explain very quickly what these numbers mean. So the first number is supposed to be a sprite group number. In this case, it's 0, because what I'm mostly concerned about is to be able to display this data. So this next number is the sprite index. So this number is actually the sprite the game is using in memory in this animation. So for example, this says I'm using sprite 159. So we check the sprite set and we go to sprite 159, and here it is. So it says I use this sprite for 3 frames, then it goes to 160. This 3 is actually the timing. So it says I go to 160, which is this one, and I use this sprite for 3 frames. Then I go to 163, which is this one, and I use this sprite for 1 frame. Then I use 163 again for 2 frames. As you can see, the frame data is different. The sprite is the same, but the frame data is different. And then it says I use sprite 164 for 2 frames, right? And we still have an attack box there. Then it says I use it again for 6 frames. There we go, 164. Then I use sprite 160 for 6 frames. So sprite 160 is this one. I use it for 6 frames. And finally, I use sprite 125. If we go up, there it is. I use it for 3 frames. So this tells you which sprite is used and how long it is displayed on screen. Okay, so now I will be explaining what these 2 numbers in the middle are. So this number, the first number here, is the X position or the X alignment for the sprite, and the second one is the Y alignment for the sprite. So here's what we're gonna do. So if you have, for example, in Photoshop, if we check, it says sprite 159. So if we check sprite 159, first we're gonna flip it so it looks like player 1, and we're gonna zoom in. Alright, so first let's look at the Y position, because this is easier. So the Y position says 97. Alright, so what we do is I'm going to draw a line. I'm going to draw a line so we can all see. So I'm going to use the pencil tool. So this is the Y alignment for the sprite. And then we go back and we check the other number. So this number says -30. Okay, so we'll take a look at this sprite, and it says it has a width of 64 pixels. So what we're gonna do is we're gonna take those 64 pixels and remove those 30 pixels, and we get 34. So we're gonna go here to position 34, which is right here. That's position 34. And we're gonna finish drawing a small line there. So this point right here, that is where the axis should be drawn. So So that concludes the explanation of what this format is. So once more, this first number is only used if you're going to be porting to Mugen, but we mostly care only about displaying the data. So this second number is actually the sprite that is being used in the animation. If you look at those sprite sets in Spider's resource, they are the same numbers used there. These two numbers are for alignment. This is the X alignment. This is the Y alignment. Okay. And finally, this final number here is the number of frames this particular sprite should be displayed in. And of course, this part here defines a collision box. This is, if there's a 2, that is a hurt box. If there's a 1, that is a hitbox. Alright, now I'm going to be explaining how to display this data. Okay, so I'm going to explain how to display the data now. So if you remember, we have in this animation, we have sprites 159, 160, and all the way to, well, we have a specific list. So what I'm going to do in Fighter Factory is first we're going to need to flip these sprites around. So we're going to flip them so she's facing to the right as if she was player 1. And I'm going to add the sprites that the output of Caddy Machine is telling me to add. So I'm going to need 159. Alright, so I'm going to add it at 0, 0. I don't need any special position here. Then I'm going to add 160. 160, and I'm going to change the index to... Actually, I should be giving them the index it's telling me, so I'm going to put 160. I'm going to rename this previous one to 159 because that was the name it had. Doesn't matter if you add them in order or in not or any random order, it's okay. And now I'm going to align them just like I discussed before. So this one is 97, 95, 80, 95. Then we also do the X alignment. So this is 34. This is 32. -12 minus 86. This one's 26. And now we're going to take a look at the actual animation already built. Alright, so this is what we're gonna do. We're gonna paste this code here to here. Hit apply, and we're gonna get this output. Here we have some well, as you can see, the same numbers are still here, but we already pre-aligned the sprites, so we don't need this data here, so we can just zero this data out. There we go. And we obtain a full animation right here. As you can see, there are some frames that are not displaying boxes. So what we can do is, like I told you before, this box should be repeated here. So all we do is repeat it. This box needs to be repeated here, so we just repeat it. and we repeat it once more. So only the hurt boxes need to be repeated. There we go. We just modified the code a little bit. We just repeated the hurt boxes where there weren't any. And there we go. We obtained the full animation. I believe that this tool already gives you a pre-assembled way of obtaining the animations. There's of course ways to do this with scripts. I mean, once you have this code, you can pre-assemble these sprite files, you can pre-assemble these animation files, and you can produce very quickly images and booklet references for all these hitboxes in a very stable and easy way to analyze, to observe. Like, every single detail is preserved, even the timing of each frame. And I believe that this is an extremely useful tool for people who wish to produce reference materials such as wikis, and just have a very tight control over the frame data and preserving everything that has to do with these two games. I myself have produced several scripts that pre-assemble sprite files, that pre-assemble some animations, but right now in the current state they're not ready. But in their current state they're not very streamlined and friendly to use, but all the data is available. My wish is to eventually prepare these tools so they become mainstream, so they become easier to use, especially ones that produce such sprite files, so they can be very quickly produced. But if anyone else is up to the task, go ahead, everything's open. You can find not only the link to my tools in the description, you'll also be able to find a link to the Sprite's resource page that has the sprite sets, and you will also find a link to this tool that I was using to look at the frame data, which is Virtual Tech Fighter Factory. And finally, I would like to say that I will be working. Well, I'm still actively improving these tools, but I haven't had enough free time lately to work on these tools. There's a lot of work and other activities that involve paying the bills. Alright, so thank you for watching, and I'll keep everyone updated on any news regarding my tool and any updates I manage to do in my free time. I'll make sure to post them and keep everyone up to date. Thank you.